Welcome to a lesson with Dr. Pal. This and in the next couple videos, we will be setting up a Riemann sum that we can take a limit of to actually determine the exact value of this definite integral. Indeed, if we look at this definite integral and compute it, in fact, you might actually notice that this function right here is just a shift of x squared. And so maybe there's a simpler way of doing this. However, let's just walk through the computation for practice. X cubed over 3 minus 2x squared, because x squared over 2, plus 3x, and we're going from 1 to 3. Okay, so we, on inputting this 3 in here, and inputting this 1 in here, and subtracting, you can check, but you should get -4/3. So what we'd like to do is set up a Riemann sum that whose limit, so it needs to depend on something, and as that something heads to whatever it's going to, it needs to make the rectangle skinnier and skinnier and skinnier, and the result should be -4/3. So that's our goal here. So let's get started. First off, we want the number of rectangles to vary, because we want to increase how many rectangles we have, because if you make the rectangles skinnier, you're increasing how many you have. So let's kind of make n, the number of rectangles, be the parameter that we're going to use and base and make it off of. In fact, we're going to turn our Riemann sum into an expression that that's in terms of n, and then we just take a limit of that expression. So let's see how to do that. We're going to take a couple videos to get there. Right here, first of all, let's think. If we split this into n rectangles, we're splitting up our interval into n pieces, and let's make each width be the same for all the rectangles. So so we're going to have n rectangles, or n subintervals, but we're splitting this into n pieces, and each has an equal length or an equal width. The equal width, what is it? Well, you're taking a length of 2, and we're dividing it into n pieces. So you take 2, divide it into n pieces. What are you left with? 2 over n is what you're left with. That's the width. 2 over n is the width of each one of these guys. So let's take a look at just the first rectangle, and it's going to be formed right here. Now, notice in the picture, the rectangle would be going downward, and we're going to use the right-hand rule. So that means we're going to be picking the right end of each subinterval. In particular, let's look at the first subinterval here, just to kind of get a feel for what's going on. It goes down to the function right there and over. It's going to be, this is really what the first rectangle will look like. And let's look at that interval. It goes from 1 and to 1 width over. So we add 1 width over, and this is what we're going to, the x value that we plug in to the function to get the height that we're interested in. It's going to be a negative height, but that's okay. That's perfectly fine for computing this, because we're computing net area, and if we're below, it's going to be negative area as well. So that's perfect. So 1 plus 2 over n is the x value that we're plugging in to the function to get the height. It's on the right, and that's for the first rectangle. Now, what do we plug into the function to get the height of the second rectangle, which will also be negative? Well, we just simply go 1 more width over. 1 more width over. So looks like we're going to have, x is equal to 1 plus 2 over n times 2 widths over for the second rectangle. Likewise, if we keep going, we see a pattern. For the third rectangle, we'll be going 3 widths over, so 1 plus 2 over n times 3. And in general, for the kth rectangle, because we're going to have lots of rectangles, we kind of need to know what it is in general for the pattern. And here we can specify the pattern by making the k as a parameter or as a variable. The kth rectangle will, we will be finding the height at the right end of the subinterval, the kth subinterval, and that's going to be k widths over from 1. So 1 plus 2 over n times k is going to be the x value that we would plug into the function to find the height of that rectangle. So the height of the kth rectangle is simply this guy plugged into the function itself right there. And we'll keep going with this in the next video. Thanks for watching.